Today, I'm going to do more examples. We still have two more. So for example number 5, we have weight of crate. This box has a weight equal 600 kilonewton. We need to determine the forces in cables AB, AC, and AD. So for this cable, we have a force here. We have a weight. Any weight is down, vertically down. How much? 600 kilonewton. This weight at point A is connected to 3 cables, or 2 cables and 1 strut, AD. So we have a force here, this force called FAB. We have another force here, this force called FAC. We have another force here, we can assume it like this, any direction as you like, FAD. At point A, all of these forces, we have 4. All of these forces intersect at point A. And point A is in equilibrium. So we need to figure out what are the forces in cables AB, AC, and AD. The typical steps for this kind of problems, we need to break each force to 3 components. Let's start with the most easy one, for weight. We have a weight equal 600 kilonewton. Can you tell me what is the weight as a vector? We don't have anything in X. We don't have anything in Y. And we have negative 600 in Z direction. So weight as a vector, 0x, 0y, and the negative 600k. If you would like to figure out the other forces, FAB, FAC, FAD as a vectors, I believe we don't have any angles. We don't have line of projection. So we are in the situation of coordinates. We need to figure out the coordinates of each point to figure out these forces as vectors. Let's start with point A. If you would like to figure out the coordinates, I believe the first step, we need to figure out what is the axis. We have here x-axis. We have here y-axis. And we have here z-axis. So this point is 0, 0, 0. If you would like to move from point D to point A, what will be the coordinate of point A? I think for point A, we don't need to move anything in X. I believe X will be 0. In Y, I'm gonna move in Y6, positive. In Z, I'm gonna move in Z 2.5. Point B. What are the coordinates of point B? Here is point B. I'm gonna move in X direction, negative 2. In Y direction, how much? Nothing in Y. In Z direction, how much? 4, positive. Point C. Here is point C. In X direction will be positive 2. In Y direction is 0. In Z direction, positive 5.5. Point D, 0, 0, 0. point D 0 0 0. If you are lucky, if you are good, these coordinates must be correct. If something wrong, everything coming will be wrong. Any question so far? Any question? So please pay attention. Please be patient to figure out the coordinates of these forces. Of these points. Point A, B, C, and D. At point A, we have 4 forces intersect. The vertical weight, FAD, FAC, FAD. So we need to figure out the coordinates of point A, B, C, and D. First step, please go ahead and figure out where are the axes. X-axis, Y-axis, Z-axis. Here is the origin. Point A, we would like to move in X, nothing in X. In Y, 6. In Z, 2.5. From point D to point B, from the origin to this point, in X, -2. In Y, nothing. In Z, +4. For point C, in X, +2. In Y, nothing. In Z, 5.5. And point D, you are lucky, point D at the same location of the origin will be 0 0 0. That means for force AB, FAB as a vector will be FAB as a value time. I said AB. AB. So B minus A. Second point minus the first point. So -2 minus 0 will be -2i. 0 minus 6 will be -6j. +4 minus 2.5 will be +1.5k. Divide these numbers square. 2 square plus 6 square plus 1.5 square. So using my calculator, this term will be 4 plus 36 plus 1.5 square under square root will be 6.5. So your final answer here will be FAB time. The first one will be 0.307 I negative. Negative 0.923 J positive 0.231 K. This is the first force FAB. Second force FAC. So for FAC, FAC as a vector will be FAC as a value. I said AC. AC. So point C minus point A. 2 minus 0, 2. 0 minus 6, -6. 5.5 minus 2.5 will be 3. So we have 2, -6, 3. So we have 2i, -6j, 3k. Divide these numbers square. So this term, the denominator, how much? 4 plus 36 plus 9 is 7. So the final value will be FAC 2 divided 7, 0.285 I. Negative 6 divided 7 will be 0.857 J. 3 divided 7, 0.428 K. Next, We have the last force for FAD. FAD as a vector equal FAD as a value time. I said AD. AD. So point D minus point A. 0 minus 0 is 0. 0 minus 6, negative 6. 0 minus 2.5, negative 2.5. So we have 0i, negative 6j, negative 2.5k. That's right? Yes. Divide this number square. I don't care about the sign, positive or negative, because a square will cancel these signs. So this value will be 36 plus 2.5 square under square root will be 6.5. So FAD time 0i minus 6 divided 6.5, 0.923 j negative 0.385 k. Do you have any more forces? Do you have any more forces? No, we have 4. Wait, we are done. Force AB, force AC, force AD, we are done. And AC. Final step or last step in this problem, point A or particle A is in equilibrium. That means summation of all x component equals 0. 0 in x component, this value in x component, so we have 0, we have 307 negative 0, negative 0.307 FAB. What else? We have this value 0.285, positive 0.285 FAC. We have this value, which is 0, equal 0. Summation of all, don't forget any, please. X component, X component, X component, X component in each force in this problem equal 0. Second one, summation of all y components equal 0. So go back one by one. Y component plus y component, which is negative 923. So we have 0, negative 0.923 FAB. We have here negative 857 FAC, and we have here negative 923 FAD. All of them together equal 0. So y component plus y component plus y component plus y component equals 0. Last one, summation of all z component equals 0. So what do you have here? We have negative 600. We have positive 231. So 600 negative plus 0.231 FAB. We have here in Z positive 428 FAC. What else? We have here negative 385 FAD equals 0. So finally, Z component plus Z component plus Z component plus Z component equals 0. How many equations do you have? We have 3 equations. This one, number 1, number 2, and number 3. We have FAB, we have FAC, we have FAD, unknowns. We have 3 equations. Mathematically, you can solve these equations to figure out the values of FAB, FAC, and FAD. So FAB, FAC, FAD. I can use my calculator, just a second, to figure it out. System 3. So what do you have here? We have negative 0.307. We have positive 0.285. We have 0 equal 0. What else? We have negative 0.923. We have negative 0.857. We have negative 0.923 equal 0. We have here positive 0.231, positive 0.428, negative 0.385. On the other side, we have positive 600. So FAB will be 410. FAC 442. And for FAD will be negative 820. I think what was the unit? Kilonewton. So this force kilonewton, this one kilonewton, this one kilonewton. As I told you guys, you can use your calculator. Each calculator has a different technique to use it in solving this equation. In your exam, I will be satisfied if you set up this equation correctly. And you don't need to reach out these final results. It's okay. I can accept it only in one condition, only in one condition. You set up this equation correctly. But if you have a mistake, I will not give you the full credit, okay? Any question? So if we do the calculation, do we make more points on the question? Set up until this point. If you set up everything correct, guarantee I will give you the full credit. Okay? If you do this, probably I will give you extra 2 points. Probably you have a mistake in a different problem or something like this, so extra 2 points to get the final answer correctly using your calculator or your mind or anything. It's okay, I will give you extra 2 points. If you stop here, you will get the full credit. If you get the final answer like I did, I will give you extra 2 points. Okay, Mitchell? Okay. I have another problem like this one. This one, we have a trick here. We have a hint. You have to be careful about it. We have a system. Actually, we have a force or weight, W. We have a weight, W equal 100 pound. So this W equal 100 pound. Okay? And this weight at point A is supported by this rope or this cable and this cable and this cable. we are looking for the forces in these cables, AB, AC, and AD. So if you can figure out how many forces, please don't forget any. We have a weight, we have a force, FAC, we have another force, FAB, we have another force, FAD. Please, one by one. All of them intersects at point A, and point A is in equilibrium. Let's start. I'm gonna start with the most easy force, which is the weight. Let's start with the weight. Weight as a vector equal 0I, 0J, and negative 100K. I'm gonna start also with FAB, because FAB is very easy force. FAB as a vector will be, anybody watching or anybody noticing what's going on with force AB? AB is a force coincide with x-axis, positive x-axis. Do you agree? Point A at the origin, point B on x-axis. So both of them should be on x-axis. So force AB exactly coincide with x-axis. So FAB as a vector equal FAB in x, 0 in y, 0 in z. If you have a force in x-axis only, so this force will be the x component. We don't have y component, we don't have z component. Like weight, exactly. Your weight in z direction only. Negative z direction. So we have negative value in z and all other components are 0. What else? Let's start with FAC. Let's do FAC. I think FAC we have projection line. Do you agree? We have here this line with angle 60 with FAC. And this line, which called projection line, has angle 30 with positive y-axis. So we are in the situation of projection line. So go back. We have 2 steps to break this force to 3 components. Do you remember the first step? We need to break this force between the projection line and z-axis using angle 60. So the projection line value will be FAC cosine 60. Why cosine? Because this projection line is adjacent to this angle 60. That means the component will be FAC sine 60. Next step. This projection line component will be broken with y and x. Actually, positive y and the negative x. So using angle 30. So we have FAC cosine 60, which is the projection line component, cosine 30, because this component adjacent to this angle 30. And this one will be FAC cosine 60 sine 30. So finally, FAC as a vector equal x component negative FAC cosine 60 sine 30 I. Y component positive. FAC cosine 60 cosine 30 G. Z component positive. FAC sine 60 K. I think I can simplify this one. So cosine 60 times sine 30. This value will be negative 0.25 FACI. What else? Cosine 60 cosine 30. This one will be positive 0.433 FACG. This one will be sine 60 will be 0.866 FACK. So we are done with the weight. We are done with force FAB. We are done with force FAC. We still have force AD. We still have force FAD. I'm gonna clean up this myth and to figure out what's going on with the remaining force. FAD. What do you think about FAD? Wow, we have three angles. Actually, we have two, but we can figure out the third one. The first angle, what is the angle between this force AD and the x-axis? 120. So I'm talking right now force FAD. So alpha equal 120 degree. Anybody can tell me what is the angle beta? Beta between this force AD and y-axis, positive y-axis. Positive y-axis. 60? No, it's not 60. Yep, thank you, John. Yes, guys, just to remind you, alpha, beta, gamma must be between the force and positive directions of axis. What do you mean? I mean, if you have a force and you have these axes, x, y, and z, and this angle 60. Between what? Between the force and the negative direction of y. I cannot accept it as a value for beta because the actual value of beta must be between the force and the positive direction of y. Here is beta. So the total angle is 180, subtract 60, so beta will be 120. Do you think gamma is given? No. Gamma not given. Okay, gamma is unknown. Can you figure it out? Yes, I can. I know cosine square alpha plus cosine square beta plus cosine square gamma equal 1. So cosine square 120 plus cosine square 120 plus cosine square gamma equal 1. I can figure out the value of gamma. And from this value, gamma will be obtuse angle. I'm sorry, acute angle. Acute angle. So cosine 120 square plus cosine 120 square times -1 to the other side, square root. So gamma will be 45 degree. That makes sense. 45 degree. So this force FAD as a vector will be FAD cosine 120i, which is alpha, FAD cosine 120, which is beta j, plus FAD cosine 45, which is gamma k. I can simplify this equation. Negative 0.5 FAD I, negative 0.5 FAD J, and the positive 0.71 or 707 FAD K. I am done with all of them. This problem is critical a little bit because we have two different techniques. The first one, projection line. How can we figure out cosine sine, sine cosine, all of these stuff? And the second one, we have alpha, beta, gamma. And the third one, we have a force in the same direction of an axis, x-axis. We are done with all of them. Remember, these forces are in equilibrium. That means summation of all x component equals 0. So this x component plus this x component, so we have 0, negative 0.25 f what? FAC, and we have here, I think I forget something here. Yeah, I forget this one. FAB I need to be organized, I'm sorry. Plus FAB, negative 0.25 FAC. The last one, how much in X? Negative 0.5 FAD. All of them equal 0. Summation of all Y component equals 0. What do you have here? We have 0. We have 0. We have positive 0.433. We have 0 plus 0 plus 0.433 FAC. And what else here? We have negative 0.5 FAD equals 0. Then finally, summation of all Z component equals 0. We have negative 100, we have 0, we have 0.866. Negative 100, positive 0, positive, I think. Yes. 0.866 FAC. And what else here? We have positive 0.71 FAD equals 0. Solving this equation together, number 1, number 2, number 3, I can figure out the value of FAB, the value of FAC, the value of FAD. If you stop here, you will get the full credit. If you can use your calculator, like I'm doing right now, I will give you 2 extra points. So, system 3 equation. 1, positive 1, negative 0.25, negative 0.5 equals 0. 0, positive 0.433, negative 0.5 equals 0. We have 0, we have positive 0.866, positive 0.71 equal 100. Oh, I did something wrong. one more time. Sorry, guys. We have 1, negative, that's right. 0, -3, negative 0.5, that's right. Yeah, this one is wrong. 0, 0.866, 71 equal 100. So FAB will be 46.12. AC will be 67.5. AD will be 58.5. What was the unit? Is it in pound? Yes, pound. So this force will be in pound, pound, pound. If you did these numbers correctly, you can get extra 2 points. So if you go back for this module, particle equilibrium in 3D, the same concept. Break each force to 3 components. Then summation of all x component equals 0, summation of all y component equals 0, summation of all component in z equals 0. That's it. That's it. The only key between a problem and another problem, how to break each force to 3 components. This is the key in any problem in 3D. If you look to your homework, for this one, for example, we have traffic sign. Weight of this traffic sign equal 300 kilogram. By the way, do you remember I told you if the weight is given in kilogram, please multiply this value by 9.81 to convert it to be in Newton. So we have a weight here equal 300 times 9.81. This is the first one. Second one, we have a cable here. We have another cable. We have another cable. So this point called A, this one is B, this one is C, this one we can call it O, for example. We need to figure out what is the value of FOC, what is the value of FOB, what is the value of FOA. I believe we have x-axis, y-axis, and z-axis, so I can figure out the coordinate of point A, coordinate of point B, coordinate of point C, and the coordinate of point O, which is the intersection of all these forces. O will be 0, 0, 0. For example, point A. Point A, I think, will be 4 in X, will be negative 8 in Y, will be 5 in Z. For point B, I believe will be negative 6 in X, in Y will be negative 8 also, in Z will be positive 5 also. For point C, in X, how much in X? We don't have anything in X, 0. In Y will be 8. In Z will be 5. Once you figured out the coordinate of these points, I can figure out the vector for FOC, FOB, FOA. The second problem, we have a force F1 with angles 45 degrees, 60, and 120. Everything is given, alpha, beta, gamma. That's it. For F2, F2 passing through this point, which is 0, 0, 0, and this point, which is where the coordinates are given. So I can break this force to component. For F3, this F3 as a vector will be 0 in x, negative 0.5 in y, and 0 in k, because this force is in the negative direction of y-axis. What else? Please neglect this force. I'm sorry, we have a mistake here. This B is not exist. We don't have B here. We have only three forces, F1, F2, and F3. That's it. The problem asking for a check if these forces are equilibrium, so go ahead and check. If you found summation of all x component equals 0, summation of all y component equals 0, summation of all z component equals 0, if this happen, then the forces will be in equilibrium. If this not happen, the forces are not in equilibrium. That's it. For this one, we have a weight here. How much? 400 Newton. At this point, we have three forces, this one, and this one. We have coordinates x, y, and z. So please be careful when you're trying to determine the coordinate of point B, coordinate of point D, coordinate of point A, coordinate of point C. You are done? So in your homework, we have three problems. I covered two of them. And the third one, it's very easy. Just go ahead and figure out the coordinates, and you can figure out each force as a vector. Which one? F2? Which one? Are you talking about problem number 2, Bichel? Number 2. Where is number 2? Here you go. F2, no. F2 not in x direction. F2 is passing through 2 points. This point and this point. F2 is passing through 2 points. 0, 0, 0, and negative 1.5, 3, and 3. So F2 will be broken using coordinates. F2 not in negative x-axis. No. F2 passing through 2 points. 0, 0, 0, and this point. You got it?